In this presentation, we delve into the fundamental concepts of failure analysis in complex equipment, inspired by the groundbreaking work, Reliability-Centered Maintenance, by F.S. Nowlin and Howard F. Heap. We'll explore how failures occur, their consequences, and why traditional maintenance approaches often fall short for modern complex systems. Failure isn't just about breakdowns. Functional failure is the inability of an item to meet a specified performance standard, while potential failure is a physical condition indicating that functional failure is imminent. These failures are fundamentally unsatisfactory conditions that depend on the determination of their impact and consequences. Detecting failures is a challenge, especially when they aren't evident during normal operations. Operating crews often miss hidden function failures that require special inspection. This highlights the importance of proactive monitoring and maintenance to catch failures before they escalate. Failure consequences are the foundation of maintenance priorities. Safety consequences demand immediate prevention, while operational and non-operational consequences vary in impact. Hidden failure consequences increase exposure to multiple failures, emphasizing the need for strategic maintenance planning to prevent hidden failure modes to surface. Multiple failures occur when independent failures combine, creating consequences that no single failure would produce alone. The probability calculation is straightforward, but the implications are profound, especially with hidden function items that increase vulnerability dramatically. Failures occur when environmental stress exceeds an item's resistance to failure. New equipment starts with maximum resistance, but stress exposure from operations gradually reduces this resistance, leading to failure. Understanding this interaction is crucial for effective maintenance decisions. Simple equipment has fewer functions and failure modes, often age-related, while complex equipment presents hundreds of potential failure modes with diverse patterns. The reality of complex equipment demands redundancy and fail-safe designs to manage performance and reliability trade-offs. Failure rate, mean time between failures, probability of survival, and conditional probability are key metrics in understanding equipment reliability. These metrics help in assessing the likelihood of failures and planning maintenance strategies to ensure optimal performance. Failure patterns vary, with some following a classic bathtub curve, while others show gradual increases or constant rates. Understanding these patterns helps in predicting equipment behavior and planning maintenance to mitigate risks and extend equipment life. The analysis reveals that traditional, hard-time maintenance policies often fail to improve reliability. Instead, consequence-driven priorities and monitoring actual conditions are essential for effective maintenance strategies, ensuring equipment reliability at a minimum cost.